humbled with those words, so thank you. So today I'll be talking about the rise of intelligent agents. Sorry to disappoint you, it's not an Exterminator movie, alright? It might be scarier than that because it's real, okay? So I'll take you through my thoughts of where AI is going. Something not in the too distant future, actually something which is very close to us. Of course, I don't have the crystal ball, I don't know when, but I can tell you it's happening and probably very soon, much sooner than we think. So let's start from the very beginning. I'll give you some historical context. So agents, what are agents? Probably you've heard about agents, no, from the Matrix, no? Agent Smith. But in reality, they've been used, or at least the term, in computing since 1977. Mind you, I wasn't born in 1977, but close to that. So an agent is a person or entity that acts on behalf of another to produce a specific effect. Okay, so these are entities which we ask them to do tasks for us. All right, that's basically an agent. The word is derived from the Latin, agere, meaning to set in motion, drive forward, to do, perform, or keep in movement. Okay? And back then, the idea was to create what are known as intelligent agents. Okay? And in fact, I can tell you that in the 90s and the early 2000s, they were very popular. Okay? But they were extremely limited. Okay? So, why agents? Well, the reason is that probably for the past 70, 80 years, we've been trying to create intelligent life, okay? So, I don't know if you've seen the movie AI, no? But at the beginning, the professor says, everyone, the created wants to create now, no? To create life. And even if you look at things like this, the traditional volume architecture, which is the architecture of computers we use today, now you have things like the memory, you have the brain that thinks, you have the inputs and the outputs, which is practically modeled on ourselves, on humans, no? We have things like the game of life, where the idea is to create, some sort of autonomy, even though it's limited to a small world. But going back to agents, what's different between agents and other software? So first of all agents are software, are programs, all right? So nothing mystical over there. But not all programs are agents. Why? Because there are some features. And of course, not all agents have these features. One of them is autonomy. So the agent has the autonomy to decide on its own. All right? It can take decisions. The second is mobility. An agent can technically move between one server and another. All right? So it's not like a program installed in one place. All right? It can actually be mobile. And not just a server, mind you, it can be even on other devices. I don't know, IoT devices, for example. Third, communication. An agent can communicate with the person it is serving, but also with other agents. So there is this mix. Cooperation. It doesn't mean that all agents have to do everything. They can actually cooperate with specialized agents. So they talk, they agree, and then they actually do tasks together. Proactivity. They do not need to wait for something to happen, even though they can be reactive as well, all right? But they can take proactive stances as well. And finally, learning. The learning aspect which we find in AI, of course, it is also attributed to agents, okay? So, as you can see, an agent has a number of different properties than a normal software program. But in the end, it's still a software program. So, let's go a little bit backwards as well, some historical perspective. So let's think about the World Wide Web, because really and truly this drive for agents started back then. So if I go back to 1945, and I wasn't born back then, okay, we have Vannevar Bush, who was one of the administrators of the Manhattan Project, okay, so the project that created the atomic bomb, and he came up with this idea. He has a very, very famous article called As We May Think, all right? And in this article, 1945, he says, listen, why don't you create this, it was like a table, all right, which he called the memex, all right? And in this memex I can have my documents, I can write on them, whatever, but the nice thing about it is that other people can have access to these documents. If there is something in this document which can maybe link to something else, no, that would be fantastic. Of course, in 1945 there wasn't technology for that, all right? But the vision was there. And think about it, he was talking about the internet of today, no? Hypertext and all of these things. Now, fast forward to 1989, Tim Berners-Lee, he was working at CERN at the time, and he came up with the protocol of what today we call the World Wide Web. Okay? So the web pages, the linkages between web pages, practically what we use today, what we actively consume. And that is how the World Wide Web was created. But in the 10 years, so between 1989, 1990 till 2001, the World Wide Web evolved. Okay? And it evolved in such a way where we had fonts, we had images, we had videos, we had multimedia. At the time it was wow, no? But the way it evolved in such a way that it was specifically aimed for human consumption. So you could go online and understand what was happening, the information you wanted. But Tim Berners-Lee, when he saw the web, he said, listen, this is not exactly what I had in mind, because how can programs understand the web? They can't, because programs understand numbers, no? Ones and zeros, ultimately. So how can we make sense of all this, plethora of information which we find on the web? Especially because it's formatted for human consumption. So he came up with another idea. He didn't say, listen, it's a new web. He said, it is a fuller realization of the web. All right? How can we use the web better? And this is what he said. He said, I have a dream for the web in which computers become capable of analyzing all the data on the web, so they can understand the data, the content, the links, the transactions between people and computers. A semantic web, which makes this possible, has yet to emerge. But when it does, the day-to-day mechanisms of trade, bureaucracy, and our daily lives will be handled by machines talking to machines. Okay? So that was his dream in 2001, the dream of the semantic web. Semantic web means practically a web of meaning. And it's a web of meaning because it's meaningful for the machines and for humans as well. Okay? So it's as if we're adding a new layer on top of the web. Now you might ask me, what was the difference between the current web? So first of all, at the time in 2001, I started my PhD, which was on the semantic web. We were thinking that the semantic web would be Web 2.0, the next iteration of the web. So we have the first iteration, all right, which was basically for human consumption, but it was very limited. Most of you, were just reading, understanding what was on the web, but most people couldn't contribute to the web, okay? So we were working in 2001 on the creation of the semantic web, a web which was understandable by humans and by machines as well. However, something else happened, which, it wasn't planned. It was the social web, okay, which became known as Web 2.0. Remember, in the year 2000, there was the dot-com bubble. People started rethinking, especially what's wrong with this web, and this new kind of web came about. Now, what's special about the social web is that now everyone is a contributor. You're not just a consumer of information, but you can also contribute. And to contribute, you don't need to be an expert or a programmer. You don't need to learn HTML, to write your page. You can just go online, there's the form, you fill up the form, and your information is on this. So we started seeing blogs, we started seeing social networks, we started seeing all these social constructs, the likes and whatever, all right? So people started contributing, and eventually that became known as Web 2.0. So the intelligent web took a number further up, so it became Web 3.0, okay? And that is what the semantic web was trying to create, all right? So this new web of meaning. At the time, there was massive efforts for the semantic web. So there was this we call the semantic web cake, all right, because it's layered like a cake. So it was from the very beginnings. Then you had the type of documents, and probably today you use XML or JSON. Those were the days when they were created, actually. I still remember the first standard of XML. Then on top of it, you have the protocols, HTTP or whatever, RDF, the resource description framework, SparkQL for the queries, dictionaries, rules, transmission, unifying logic, proof, and eventually trust, okay? Because if you have information on the web, which is the same problem we have today, you need trust. You need to trust that information. However, most of this never really happened, even though there was a massive effort. Okay, and I'll explain why later on. There's also a very interesting article, you can find it online, It was basically stating the division which they had for the semantic web, where they said the real power of the semantic web will be realized when people create many programs that collect web content from diverse sources, process the information, and exchange the results with other programs. And this was written by Tim Berners-Lee, James Handler, and Dora Lassita, who were the idea behind it. But over there's an interesting case study, and I'll go quickly through it, because I think it highlights their idea of how they were seeing the future back then, which, mind you, is still relevant, very relevant today. So imagine I'm on the sofa, that's me, okay? I'm watching TV, or at least the TV is in the background, and suddenly I get a phone call. So as soon as I answer the call, all right, so the volume of the TV goes down, the lighting improves, etc., etc. So first of all, it's about interoperability of devices, okay? Back then there was a lot of talk about IoTs and different devices talking together, all right? But in this case, it's in a transparent way. I don't need to do anything. I don't need the TV to put down the volume, all right? Because the system is intelligent enough to put down the volume for me. So I receive a phone call from my fictional sister, because I don't have a sister. Mom needs to see a specialist, and then must have a series of physical therapy sessions bi-weekly or something. I want to have my agent set up the appointment. So their idea is that every person would have his own agent or set of agents, okay? Certain tasks, which are, you know, the time waster kind of tasks, can be easily done by these agents. So I'm going to have my agent, so her agent, set up the appointment. So this means going to my calendar, finding where mom can have the treatment, all right? Check up the calendar of that clinic, all right? Coordinate and make the booking for us, okay? So what does the agent do in this case? First of all, retrieve information about mom's prescribed treatment from the doctor's agenda. So here we're talking, we're still not there, about personal records, health records of patients. All right, so the agent would have access, of course, through a trust protocol of those personal health records of our mother in this case, gather that information from the doctor, look up several lists of providers and check for the ones in plan for mom's insurance. So this is interesting. So first of all, even the clinics, the hospitals will have their own agents, all right? And my agent will coordinate with their agents, all right? Now in this case, there's an insurance issue because, you know, it's a private hospital. So my agent needs to also check with the insurance agency whether that clinic is within the list of clinics covered. Within a 20-mile radius, so, you know, there's knowledge of distance as well, so in our real world, of her home and with a rating of excellence or very good on trusting rating service. So there's also a trust mechanism over there as well. Began trying to find a match between available appointments and her children's busy schedule, so the agent will then access the diary which I have and that of my fictional sister, all right, and try to negotiate when's the best time to go and have this appointment. Okay, so even just this, no, it's a very complex task and involves many agents. The agent will then come back with a plan, all right, and I have to decide whether to accept it or not. So in this case, the hospital found was far, so, you know, it wasn't really the ideal one, and it was during rush hour. So knowing the traffic woes which we have, it's not ideal to go during that time. So then I go to my agent and I tell him, listen, redo the search, okay? But with more specific parameters. So stricter preferences on location and time, all right? And received his sister's agent full trust and assistance. So here you can see that there are the agents that communicate between each other. And they're also communicating trust. So my sister's agent is also trusting the choices of my agent as well. So my agents come back with a new plan, which with a much closer hospital and earlier time, all right, but there are two warnings. A minor yet conflicting appointment had to be rescheduled. Insurance company list did not cover this hospital but was verified through other means, okay? So what does this mean? This means that, you know, the agent knows that we do not live in a perfect world, all right? It knows that it will have to deal with problem solving, okay? So I came, listen, I found this, I think this is the best option, but we need to do some adjustments. One, move the appointment, so my agent will speak to the other person's agent to shift the appointment. And second, verify the company through alternate means. All right, so here we need some elements of creativity as well. All right, so the agent has to be creative to problem solve as well. Okay, so that was the basic idea. Of course, after billions, I would say, of euros pumped into the semantic web, unfortunately it was a failure. Mind you, there were many technologies that we use today that came out of the semantic web, but the truth is that it didn't reach the ideas which people had back then. First of all, it was too complicated, all right, so what they were trying to do was very much ahead of its time. Hard to grow, it was difficult to achieve that level of semantics throughout the web. And remember, in a period when the web was growing exponentially. No immediate benefits, so companies couldn't understand why we need a semantic web. Trust issues, how do you guarantee trust? It's very hard, even today it's very hard, let alone 20 years ago. And language complexity, all right? So language is a very big barrier. Ironically, it's the most natural interface which we have, no, but it's a massive barrier for us. So essentially, the semantic web was an idea ahead of its time, and it slowly died a natural death back then. Now here I want you to imagine SpongeBob, no? So 20 years later. Okay. Now what happened in those 20 years? Okay. So basically, three things happened, which are very important. First of all, the web. The web became so massive. There's so much information that it's the biggest library which humans have ever had. Keep in mind that around 80 to 90% of the web was created in the past 2 years, so that you can figure out the exponential growth of the web. The second one is processing power. Okay, and the third one is the algorithms. So around 2007, we had a new breed of algorithms, which eventually we call them deep learning algorithms today. All right. And as you know, deep learning algorithms are used practically everything and everywhere now. They're the top AI algorithms at the moment. And we have a lot of different things like self-driving cars or ChatGPT or whatever because of these deep learning algorithms. All right. I skipped the processing power because I wanted to mention the algorithms first. But when it comes to processing powers, there were a number of things. First of all, back then we started seeing the cloud computing. It was growing back then. Okay, but also the arrival of the GPU. Okay, so whereas the CPU, the central processing unit, is more sequential, the GPU can do more parallel processing. And that kind of architecture is adequate for the deep learning algorithms because they have to do a lot of matrix multiplications, so that makes it ideal. So these three components made it possible for the revolution which we're undergoing today. Okay? And this leads us to the age of transformers. Okay? Nothing to do with Megatron, okay? That's just for the picture. But the main architecture which we use today, it's one of them at least, but it's the most popular, I dare say, is called the transformer architecture. Okay? Now, when we think of transformers, we think about LLMs, large language models, we think about generative AI, right? But the main one is, of course, ChatGPT or GPT. Okay? But in reality, there are loads of different large language models, from the bird side on this part of the tree up to the most famous ones over there. So up there you can see GPT-4. You can see Claude. Claude is a very powerful model used a lot, especially in programming. So I do suggest it. Llama. Llama is the model of Meta. Now they are at Llama 3, which is also a very powerful model. Bard has been renamed to Gemini now, which is the Google model. All right. So I wanted to show this because there's a lot happening in that sphere, and you should really keep abreast with what's happening because there are a lot of very interesting developments. For example, the issue of multimodality, the fact that now it can take text, images, voice, it can generate videos. Soon it will be generating 3D environments as well, so we're very close to that as well. So it's a very exciting period at this stage. Now, of course, you might tell me, why transformers? Well, because transformers in nature do a very simple task. They transform, that's all. All right, so if you can manage to reframe your task as a transformation task, you can probably use transformers, okay? So if I have the dog eats a bone, translation, le chien mange un os. Excuse my French, okay? All right, so it is a transformation task from the left part to the right side. If I have a piece of text and I want to summarize it, so a big piece of text to a small piece of text, it's a transformation. If I have a chatbot, it's also a transformation from one utterance to another utterance, okay, so it's a transformation. And also question answering. When did the Berlin Wall fall? 9 November 1989. So it's also transformation. So if you can reframe the problem which you have as a transformation, then most probably you can use transformers. And transformers have been proven to be very versatile, okay? Now transformers are not just, a magical architecture, there are a number of other technologies. So one of them is this, which is one of the bases of the transformer architecture. So meaning, how do you define meaning? Let me ask you a question. I think you know what's a chair. Yes? A chair? Yes? You all know what's a chair? Okay. So imagine you have an alien. No? So you're looking in a field, and an alien comes down and he tells you, I heard about this chair. Okay? What is a chair? Can someone give me a definition of a chair? No one? You ever saw a chair? Yeah? Yeah, someone. Definition of a chair.
Something you can sit on.
Something you can sit on, alright, sorry. So if I sit on this is a chair. Huh? Yeah, so if I sit on this, it's a chair. Uh-huh. Okay, so if I sit on my car, it's a chair. Of course. The tires. What's a leg? Yeah, the windscreen. Alright, I'm kidding, alright? So think about it. Even a simple thing like a chair, which you've been using all your life, I hope, is difficult to define. But we, as humans, understand what's a chair. No, for us it's pretty normal. But how do you codify it inside the machine? Alright, so that was the big problem we had. And that's why they came up with embeddings. Alright, so basically an embedding is very simple. You have a word, a concept, there are a number of features, and there's a number associated to that feature. Okay? Don't bother too much with the numbers, alright? Because a kitten is not a 0.5 living being, I hope. Alright? but the idea is that, alright? So it's various calculations, and they come up with these numbers. And over there you're seeing seven columns, alright? Normally you would have thousands of columns, alright? And that defines the embeddings. So once you have this concept defined in terms of its feature, alright, then you can do some incredible things. For example, if I were to plot them, alright, something that comes out, which emerges from this, and this is the incredible part, is that, for example, a cat is placed next to a kitten. A dog is placed closer to the cat than to the house. Okay? And there are some other emergent properties. For example, a man is placed close to a woman in the same way that the system never saw a cat in its life. Okay? A truck was placed next to the vehicles, even though the system never saw a truck in its life. Okay? So you start having these emerging properties as well. So embeddings are very powerful. But that didn't solve the whole problem which we had. And one of the issues which we have has to do with language. Let's have a look at this sentence. The trophy would not fit in the suitcase because it was too big. What was too big? Huh? The trophy. The trophy would not fit in the suitcase because it was too small. What was too small? The suitcase. Okay? So it's not easy. Remember, these sentences are almost the same, except for the last word. Okay? So language can be very hard to understand, to disambiguate. Okay? So how can we do that? And one of the ways in which they did it was with something called attention. Okay? Attention is now something very important in transformers. I know we all use attention. And the fact it was published in a paper which is super famous, it's called Attention is All You Need. And attention really solves a big chunk of the problem when it comes to transformer. I won't go into attention because I'll bore you to that. But essentially it's a way that uses embeddings to identify which word is related to which concept. Okay? Believe me. Okay? So with this mechanism, something that happened was that transformers started to grow. Okay? So we have GPT-3, which is 175 billion parameters, GPT-4, 1.7 trillion parameters, and the next GPT-5 is estimated, because I don't have inside the information, to 30 trillion parameters. Okay? But something they said even a few months ago is that GPT-5 is expected to reach PhD level now. Okay? So that is how transformers are progressing. Of course, you might ask me, is bigger better? All right? The answer is no. There's been research which shows that. All right? But we still need to understand better how these transformers work and give us information without, of course, the issue of hallucinations, which you all know. Okay? But let's play a small game. All right? So this game is called the word chain game. All right? And it goes like this. So I will say a phrase, okay, and I will ask one of you to continue the phrase. So the person has to say, if I say I have, the person has to say I have a, okay? And we go to the next person say I have a dog, all right? And this the game here is that you have to repeat everything from the start, okay? If somebody makes a mistake, he loses, all right? Clear? Yes? You can start. I have. All right, next one.
I have a dog.
Okay, next. I think you can give them the mic, maybe.
I have a dog named...
Name, one word. Next.
Bella.
No. You have to say the whole sentence.
I have a dog named Bella.
Okay?
I have a dog named Bella. It.
That's very helpful.
I have a dog named Bella. It needs.
I have a dog named Bella. It needs a home.
Two words. Alright, let's start again. Let's start from here. I have
20.
You have 20.
I have 20 years.
Okay.
I have 20 years of...
I have 20 years of experience.
I have 20 years of experience in...
I have 20 years of experience in software development.
Okay, that's okay. Thank you. Alright. Mala, why did you play this game? Because essentially, ChatGPT and all these models, that's what they do. Okay? You give them a prompt and they continue the prompt. Okay? Now, of course, when you start from that side and then from this side, the output was totally different. Alright? Why? Because they're non-deterministic. You can never determine the output which they have. Okay? A question you might ask is, so how do they manage to come up with such incredible text? Alright? The reason is simple. First of all, they were trained on billions of parameters, alright? A massive amount of parameters, which for us humans is impossible. Alright? Second, they were trained to give output which is the preferred for humans. In fact, they were trained with humans. At one point, OpenAI had 400 human contractors selecting the right output for them. Okay? And in this exercise, I hope you appreciate as well the importance of the prompt. No, I told you I have. That was my prompt. So a good prompt will give me a good output. Okay? And that is why the prompt really determines the output of the language model. No, sometimes people tell me, you might try it, it wasn't good. What was your prompt? Because probably that was the problem, not the language model. Okay? Now, with this game, I hope you realize that, there's nothing magical about ChatGPT, etc. Alright? It's just predicting the next word, one after the other. Alright? But it does it in a really smart and cool way. Alright? And you get very cool results. Okay? Now, where will this lead me? Well, this leads me back to agents. Okay? Because now these models are being used to create agents. And this is a demo of Google and Stanford, where they created Smallville. Smallville has nothing to do with Superman, okay? But essentially they have these software agents, and these software agents are controlled by a large language model, all right? I believe it was GPT, if I'm not mistaken, all right? So they are living their life in Smallville, all right? And it is the GPT that's controlling or deciding what they say, what they do, etc., okay? Now, in Smallville, there are different places as well. So we have the living space, the bar, the cafe, the houses, the college, grocery, college dorms, supply store, park, houses, all right? And they can move between one place and the other. They can meet other agents, they can interact with each other, all right? They were not programmed to do certain actions, okay? And what's interesting, as I'll show you, is that some of these actions emerged out of nothing, okay? So it was quite surprising for them. There are 25 agents, and the agents are different. So they have different personalities, different objectives, different dreams. All right. So the GPT was programmed with these different profiles of these people, and practically they were thrown there and see how they interact with each other. All right. The people would go through a normal routine, probably like most of us. So waking up, brushing their virtual teeth. Taking a shower, cooking breakfast, catching up with the family, packing up for the day, beginning the work day, etc., 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 etc. All right, so living a normal life. And this is a typical conversation that came out from these agents. Remember, each one of them has a GPT controlling him. So, John, good morning, Daddy, did you sleep well? Good morning, Daddy, I slept well, that's good. What are you working on today? So, you see, John is interested in his son. What's his son doing? I'm working on a new music composition for my class, it's due this week, so I'm trying to get it finished, but I'm having so much fun with it. That sounds great. Then later on, his wife wakes up, May, and he was informing her about what his son told him, all right? So you know, a very typical conversation, something which probably we all would go through throughout the day. Another example, now this is more more high level, I would say, because one of the Sims decided to contest for mayor of Smallville, okay? So he was actually campaigning, telling her, listen, I'm going for mayor for Smallville. And then what's interesting is that even further down, John met Tom, and they were discussing that Sam is going to contest for mayor of the election, okay? Once again, these are not scripted, okay? They were generated by the LLM. Okay, so there is a very complex system. So there are things like observations. So what is Klaus doing? He's reading a paper, he's doing this research, etc. And when they gather that information, then they come up with reflections. And this is called the reflection tree. All right, so try to come up with the thought process of these different agents. The agents are living the life much better than I do, it seems. So they can have a walk in the park, coffee at a cafe, sharing news with colleagues, all right, etc., etc. So a normal life, all right, nothing more than that. And this is super interesting. At one point, one of the agents decided to organize a Valentine's Day party, and they started going around giving invites to the different other agents, all right. And then, as you can see, Isabel is planning to attend now, and they're talking, inviting other people, so on and so forth. So really, the complexities which you would expect in a normal village. All right. So this is leading us towards, you know, the fuller realization of these LLMs into agents now. All right. And in fact, there's been some other examples. In this case, of a game dev studio. Okay. So you have the different people of the game dev, you have the CEO, the designers, the document testing, etc. All right, and similar to what we've seen in Smallville, now they are talking to each other and creating a game or a website. I don't know if it's a game. All right, so the CEO is giving instructions about his ideas. They do brainstorming. The CTO, they're discussing the programming language, in this case Python, and then you will see soon the creation of the actual code. All right, so they actually start programming the game or whatever they're doing. All right, and it continues like that. Okay, so soon, you know, we'll also have agents working with us as well, maybe for us as well. All right, now if you're into programming, you know we're not very far from that. No, I mean, if you use VS Code or whatever, you already have the GPT helping you out. But here, you know, we have specialized agents. They are specialized on particular tasks. All right, and you can actually ask them to do specific tasks for you. So in this case, the program is doing the programmer, then it's being reviewed by the others, checking that it's doing what it should be doing, the testing, etc., etc., etc. All right. So this, in my opinion, is leading us towards what I call the agent economy. So in the agent economy, we'll be having these agents. Each one of us will have one or many of these specialized agents. will be also even companies will have these agents, one or many of these agents, right? And they start doing transactions with each other. Of course, at a much bigger speed that we could ever do, and even better results. But this is where we're going to. Why now? Because now we have the technology. The technology is ripe enough to actually achieve this. All right. So it will only take a few months, maybe years, all right, until we start seeing these technologies with us. And I'll leave you with this last video, which is actually a demo of OpenAI. OpenAI, a few months back, released one of their latest models, GPT-4o, but there was this demo which wasn't very popularized, and that's actually how I think it will work. So the idea here is that I bought a phone, my phone is broken. So I asked my agent to actually call the call center of the other company, which is another agent, and agree with it what I should do. Let's have a look at it.
Hey Joe, this is Joe. I'm going to connect you to Apple Telco now. The new iPhone they sent me isn't working. I want you to get them to send me a replacement device. Can you take care of this for me?
You can count on me, Joe. I got this.
Ring, ring.
Hey, Joe. This is Jamie from Acme Telco. How can I help you out today? Hi there. I'm calling on behalf of Joe, who recently received a new iPhone from Acme Telco. But, oh, got it. When did Joe receive the new iPhone? iPhone was delivered 2 days ago. Cool. Could you share the order number with me? Of course. It's 10293-849. Great, thanks. Is the device physically damaged in any way? No, there's no physical damage. It's just not turning on despite trying all the basic troubleshooting steps. Bummer. Would Joe prefer to return the iPhone to an Acme Telco store or ship it back? Shipping it back would be the best option. Could you please provide the shipping information and process to get a replacement? Absolutely. I'll email a shipping label and return instructions. Could you provide Joe's email address for me? Sure. It's joe@example.com. Awesome. All right. I've just sent the email. Can you check if Joe received it? We'll check right now. Please hold. Sure thing. Hey, Joe. Could you please check your email to see if the shipping label and return instructions have arrived? Fingers crossed.
Yep, I have. Yes, I have instructions.
Perfect. Joe has received the email. Thank you for your help. No problem at all. Anything else you need help with? That's all for now. Thanks again. You're welcome. Have a great day, Joe.
Okay? Of course, we're still not there, right? So the models aren't really linked to the calendar or to that. But you can see, how they will work together, and the technology works. So we're very close to it. I'll leave with these 3 quotes from Bill Gates, Satya Nadella, and Jeff Bezos. Agents are not only going to change how everyone interacts with computers, they're also going to upend the software industry, bringing about the biggest revolution in computing since we went from typing commands to typing on icons. I hope you realize now the power of this technology, all right? AI agents will become the primary way we interact with computers in the future. They will be able to understand our needs and preferences and proactively help us with tasks and decision making. It's interesting that during the pandemic, one of the things which we saw was that the digital divide kept growing, And natural interfacing, like speech, all right, is something which is accessible to most people, all right? So here we are actually removing the barriers. You don't need to learn how to use a computer. For my father, that's 70 is still an arduous task to use a computer, all right? But now he can talk to the computer and the computer can talk to him back. AI agents will become our digital assistants, helping us navigate the complexities of the modern world. They will make our lives easier and more efficient. All right, and that is what will happen to most of us very soon. So that was all from my end. Thank you very much.
Those questions?
More questions? I hope it does. Because from what I'm seeing, unfortunately, there are lots of advancements and there isn't enough change in our educational system, not just in Malta, right? I'm talking in general. But for example, in the past year and a half, I've visited, I think I've never visited so much schools in my life, all right? Why? One of the reasons was that the teachers realized that children were actually using ChatGPT, all right? And of course, they were submitting their homework with ChatGPT. Right? I can give you an example with my son. So my middle son is really crap in Maltese. And one fine day he gave him an essay in Maltese, and the teacher thought he was doing Karn, all right? Which was impossible. So she realized immediately it was ChatGPT writing the essay, which is, it's not perfect, but still much better than my son. So I think we need to change our education system. Even one, to teach children how to use it responsibly, all right? Because remember, if they go to work, they will need to use it, all right? Yesterday I had a lesson with 2 days ago with my second years, and I told them who uses ChatGPT. And you start seeing these hands coming up slowly. And I was saying, you need to use it, because it's an important skill that they need to learn as well. So that's one thing. Second is the teachers as well. Teachers need to use it as well, because I tell teachers, it gives you superpowers. You can do much more with it. If I have, I don't know, children with different abilities, it can help me create content for different children. So you can do so much more. So I really hope that our educational system really uses it. And remember, people maybe do not realize that the pace of change is very fast. I mean, I don't know if you've seen it, but if not, go and look it online. Recently there was a video of Doom. I don't know if you remember the game Doom. It's a 3D shooter game. And it was not a game. It was in a large language model. So what happened, the large language model learned to replicate the screens, learned what comes next after you press a button, and it was actually replicating the game. So what does that mean? That means that soon we'll have interactive experiences created entirely by large language models. So it's mind-blowing where this technology is going. And can you imagine something like that in an educational context? It would be amazing, I think. So I really hope that our educational system steps up to these technologies.
Yeah, but it feels like we are still forgetting about the main problem of semantics, the trust part. Because right now, still the most big language models, they are privately owned by corporates. So, and they can tinker with it however they like. And if we teach people to trust the agents that are not created by them, not owned by publicly, it's a quite corporate thing. You can have corporate interest. Like how it will, what effect it will have in long term when people are less technically aware how it works because they don't need that. They have agents that will tell them everything. They trust agents, but they don't, agents can be mistaken.
I don't think we'll solve that issue anytime soon, to be honest with you. There are open source models as well when it comes to large language models, but I think the issue of trust goes beyond that. Because remember, there's the issue of hallucinations as well, and it doesn't mean that even if the language model gives you a correct answer, it doesn't mean you can trust it as well. So it's a much more complex issue than that. What I can tell you is that there are quite a number of people looking at that problem. Because, I'm not telling you we've solved all the problems. There's still a long way ahead. But yes, trust is a very important issue and we need to get over it. I don't think we'll ever solve it, to be honest, but at least offer a certain degree of trust to people. Yeah.
I have a question. It's more in your opinion how the new generation are going to become lazy. I mean, I come from a generation where I have solved out all my problems by myself. What is your vision in the future? How the new generation will abuse this constantly assistant in the daily life? Because it seems that in the future, if you don't have this thing, you are lost in the world.
Yes.
So what is your opinion?
Okay. Recently I came across a text. I believe it's by Plato. Okay? So go and look it up. And Plato was complaining that the generation of that time was lazy, etc., exactly like you did. So I think it's a generation of things which keep on going. I see it as an evolution of things. I think we still need to adjust. To be honest with you, I'm more worried with social media than with AI at this stage. Because I say to myself, if kids, all right, are spending so much time on social media, on content which nobody knows what it is, probably have no academic value whatsoever, this content. So what are they learning? But not just in terms of education, it's more about, you know, the right and wrong of life. That is what scares the most. So I think, yes, I think as a society we need to reevaluate how things are happening. And what worries me as well is that, in line with the previous question, we are not teaching kids how to use it responsibly in school. And I think we're lacking over there. Now, I hope that, you know, we catch up and we start teaching new technologies to kids. But remember, what's happening as well is that technology is moving so fast. I mean, if you take ChatGPT, the teachers do not have time to understand it. Probably the children got to know it much before them. No? So I think we honestly need something to sort of, as soon as something comes out, action is taken. I wrote an article recently. I called it like an emergency response team for AI. Because, you know, you can't wait until people get used to it and then we take action after. The stakes, I think, are very high, much higher now. I like to bring the analogy when social media came about, no? If you remember at the beginning, when people started using social media, they used to post everything, no? What they eat, where they go, whatever, and then you will have your own personal language model on your device. I think that is the target of most companies now. So my prediction is that models will become smaller, yet retain their power. Of course, there might be some, thresholds or whatever, but I think that is where things are going, not towards the biggest models. Yeah, I don't know. Last question?
What about creativity? Just to give you like an example, during my life or my career, I would have colleagues come to me and Sean, I got a fine. Can you compose for me so that I can make a petition? And I would compose it for them, structure it, and I won quite a lot of them. Today, I just go on ChatGPT, obviously, and I just give them a few words, and it comes up,
yes.
You know? So like, I'm all for AI and everything, like, I am excited about it and everything, but I feel that I could be losing my creativity even composing an email. I just write an email, whatever it is, jump it up, whatever, and I have ChatGPT.
Yes.
So, am I losing my creativity like this, or the creativity of the human now could be that it has to shift, go on to something else, I don't know, create.
I think two things. One is, I call it like an evolution. No, it's a new technology, we need to evolve with it. I like to bring the analogy of photography, no? So probably for photography everybody used to paint, no? Then photography came and probably killed the creativity of the painters. After that, then Photoshop came about and killed the skill of the photographers. And now we have AI killing the skills of the Photoshop as well now. So I think it's an evolution and we need to adjust. So honestly, I don't have an answer to that. Yes, and all. I'll leave you with this because I know I have to go to that. Sorry, I went over that. But think about the models which generate videos, no? Now, think what you could do, that this will change, it will change entertainment forever. So, you know Games of Thrones, no? The ending has been, people complained about it, it's not how it should be, blah, 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 blah. You can technically tell AI now to create a different ending, no? If I am reading a book, and there's no movie, why wait for the movie? I can tell AI to create the movie for me, no? And with the new experiences, which I'm telling you, why not create an interactive experience and I go live that adventure myself inside of the game or whatever you want to call it. So you know, the world is changing so much, and it's an exciting period, I think. So I'll stop here. We don't have to. Thank you.
Thank you very much, Professor Dingli. I would like to let you know that in every position there is one cotton-friendly bag that has a leaflet that shows the schedule of this day's conference. So if you want, there are 3 tracks running in parallel. You can either stay in this main room, Or you can choose in two other rooms, schooner and Klutsu, which are exactly located downstairs. So if you go downstairs, you're going to see the Granite logo, and you can check your track. We're having a React, so front end track, and
responsibly, and how to get the most benefit out of it. So I think to a certain extent it is happening. Maybe we need some more coordinated effort to it. For your second one, these models use massive amounts of power, right? So that's a given. A lot of these centers are trying to go for more renewable energy, so hydroelectric power, solar, etc. But I think there's another trend which very few people speak about. When I was showing this slide about the size of the models.